Hi, welcome to another episode of Math Made Simple. I'm Jack, and I'm a math specialist here at the Pique Lab. In this video, I'll be analyzing a past year examination question on the topic of bearings under the chapter of application of trigonometry. I've also prepared a copy of this question for you to download for free by clicking on the description box below. So, let's get started. In this question, we are given a diagram ABC, which represents a horizontal triangular field and a vertical flagpole AP. We are told that B is 85 meters from A on a bearing of 0.25 degrees and that point C is 170 meters away from point A. We are also given length BC as 180 meters and the height of the flagpole is 12 meters. In this first part of the question, we are interested to find out the bearing of A from B. Now, let us first start by establishing what exactly a bearing is. In mathematics, a bearing is the angle in degrees which is measured clockwise from the north direction and is usually stated as a 3-digit system. Let's say we have 2 points A and B and they are separated by a certain distance apart. If we are interested to find out the bearing of A from B, we must first identify the starting point. And the starting point is always after the word from. In this case, B is our start point, while A plays the role of our end point. We shall now go to the start point and draw in a north direction, which is typically drawn in a vertical direction as shown. Now, if we are interested in the bearing of A from B, we will draw a clockwise angle starting from the north direction and we stop when it touches the green color line. So let's say this angle is 10 degrees. We say that the bearing of A from B is 010 degrees. This is what it means by a 3-digit system. Now that we know what a bearing is, let us proceed to solve the question in part AI. Since we are interested to find the bearing of A from B, we must first find the start and end point. Recall that the start point will be after the word from. In this case, B is our starting point, while A is our end point. In our diagram, we shall now proceed to point B and draw in the north direction. But what do you notice about the north direction in this question here? We see that the north is not pointing vertically upwards in the paper, but rather is in a slanted direction. So please be mindful of that and draw in the north also a little bit slanted. Now, how do we then calculate the bearing of A from B? Let us draw in the angle. It will be moving clockwise from the north all the way until it touches the line connecting A and B. So we are interested to find this pink color angle here. We will first make use of this green color angle here. Notice that in our diagram, there are a total of 2 north directions drawn for us. And because they are pointing in the same direction, we can conclude that these two are parallel to one another. And we can also then proceed to make the following deduction about these two angles here. So what can we say about the 25 degrees and the green color angle? Since they are actually created by 2 parallel lines, we say that they are a pair of interior angle. So what is an interior angle? They are just 2 angles that sum up to 180 degrees and they are formed in between 2 parallel lines. So how do we calculate this green color angle? We will simply take 180 degrees, subtract away 25 to give us 155 degrees. And with this 155 degrees, we can now proceed to solve part AI by taking 1 full revolution, which gives us 360 degrees around point B, subtract away the green color angle of 155 degrees to give us a final answer of 205 degrees as the bearing of A from B. Now let us proceed to part A2 of the question. Now in part A2, we are required to find the angle ABC. So let us start by first drawing a simple sketch of the triangular plane ABC. Angle ABC is annotated by this green color angle here. How are we going to find its value? Now notice that we are given all 3 sides of the triangle, but we do not have any interior angles of it. Hence, for this particular question, we will be making use of the cosine rule. Now, the cosine rule can help us to find unknown lengths as well as angles along a non-right angle triangle. And in this case, because we are interested to find an unknown angle in a non-right angle triangle, we'll be using this variation of our cosine rule itself. So let us plug and play the values into the formula. We'll tell them by cosine rule, cosine angle ABC is equal to. Now, one important point to note when we use the cosine rule here are the corresponding angles and the value we subtract in the numerator. How do we identify this pairing here? Because we are interested in angle ABC, if we reference our diagram on the left, take note that this A value we subtract will always be the side directly opposite the angle. So in this case, when we use the formula here, we will subtract the value of 170 in the numerator. So if we set up the cosine rule now, it will be 85 squared plus 180 squared minus 170 squared divided by 2 times of 85 times 180. Now from here, we can tabulate the right to give us 143 over 408. And to find angle ABC, we shall just take a simple cosine inverse of that fraction and get out a final answer of 69.483 degrees and hence 69.5 degrees to 1 decimal place. Let's move on to part B of this question. In part B, we are given a rate relating the cost of the plot of land to its area in square meters. We are interested to calculate the cost of the land occupied by the triangular field ABC. We will start by finding the area of this plot of land. How do we go about it? We know that the area of a triangle can be calculated using the formula half times base times height. But will you use this formula in this question? Now, it is not wrong to use it. However, it will be very tedious as it involves multiple steps. To make our lives easier, we'll use a more powerful formula that involves the use of trigonometry. The formula we'll be using is half times AB times sine C. A and B here represents two sides of the triangle, while C here is what we call the included angle that is required to calculate the area itself. Now, what does it mean to be an included angle? If we refer to the triangle above, we see that we have one angle given to us, which is 69.483 degrees, calculated from A part 2. This angle here, it is created by two sides of the triangle. Can you see which are the two sides? They are AB and BC, with values of 85 and 180 respectively. So, together, these two sides here creates the angle ABC, which is what we call the included angle. So let us plug and play the values into the area formula to give us half times 85 times 180 sine 69.483 degrees. Evaluating this, we will get out 7164.747 square meters. And to solve for the cost, we will multiply the rate given to us, which is $70, with the area found. Pushing these numbers into a calculator, we will get out $501,532.29 to 2 decimal place as our final answer. Now let us move on to the final part of this question. In part C, we are given a man who is walking along BC as shown. Recall that there was a flagpole at point A, denoted by AP, with a length of 12 meters given in the question. In part C, we are interested to calculate the greatest angle of elevation of the top of the flagpole when viewed by the man as he travels from point B to point C. Let us begin by finding where exactly along BC will we get out the greatest angle of elevation. It will be at the shortest distance from the base of the flagpole, which is denoted by point A in this diagram. So where exactly is that point? It will be a perpendicular distance from point A all the way to line BC. And it's at this point, which we will label as point M, where the greatest angle of elevation will be obtained. If we connect points P and M together with a straight line, we will obtain a very nice triangle as shown. Let us sketch out that triangle PAM. Since the vertical flagpole is placed on a horizontal ground, we note that the angle PAM is a 90-degree angle. Now, where is the greatest angle of elevation in this triangle? It will be at angle AMP. So how do we find his value? We can make use of our trigonometry concepts that we have learned before to evaluate his value. When given an unknown angle that we would like to find in a right angle triangle, we need a minimum of 2 sides. At this point, we have one side which is AP, but we do not have sides PM, nor do we have AM in this triangle. So to solve for the angle required, we must first obtain either PM or AM. Now, which side do we go for? For this question, we'll be going for side AM because we have enough information to solve for his value. Let us move back into our diagram at the top. What can we infer about AM with respect to the triangle ABC? He is actually the perpendicular height of the triangle itself. Recall from part B that we found the area of triangle ABC, which was 7164.747. Now, since we have the perpendicular height identified, we can make use of our half times base times height formula. We note that height was given as side AM, and if AM was taken as the height in this formula, what will we choose as the base? It will be side BC. By plugging in the values of BC, we can form the following equation and hence solve for the value of AM, which will give us 79.608 meters. Going back to our triangle PAM on the left, we can label AM now as 79.608. And with 2 sides of the triangle, we can now use trigonometry to solve for the angle required. AP here plays the role of our opposite side, while AM plays the role of our adjacent side. To solve for the angle required, which trigo function will we use? We will use the tangent function. Tangent of angle AMP here is going to be equal to 12 over 79.608. And by solving for angle AMP here, we will obtain 8.5721 degrees and hence 8.6 degrees to 1 decimal place. This is our greatest angle of elevation required. Thank you for watching, and I hope you enjoyed the video. If you found this video useful, please do give us a thumbs up. If you'd like to check out more videos by us, do click on the links on the right hand side of this video. Last but not least, don't forget to subscribe to our channel for more interesting videos. Thank you, and see you again next time. Bye!